All right, let's do lesson 2.4 now. All right, so the general question says which section of this position time graph represents an object at rest and how can you tell? Well, let's think about it, right? So, and this is a position time graph. This is a position time graph. It says displacement, so this is measured meters. And if we were to give these numbers, so 1, 2, 3, 4, 5, 6, right here, and this is 9. So I'm just going to write 9 here. And these are all meters, right? So this is meters, meters, meters. And basically, what you can say is that from A to B, an object is going from 0 meters to 6 meters, right? So from A to B, this is A, and this is B, it's traveling at 6 meters. And that's what's happening here. And then from B to C, we go from 6 to 9 meters. Right, so now we're at point C. Right, because your position is increasing, so you definitely have a velocity. You're not at rest. You're not sitting there. But from C to D, what you guys do see is that while your C is at 9 meters and your D is at 9 meters, and well, are you moving anywhere? Does the graph say you're moving anywhere? Well, no, you're not really moving anywhere at all, right? You're staying at a position of 9 meters. So in essence, you're not really moving. And so you are at rest here. And that's how you can tell, right? You're essentially not moving from your position. Move on to the next question. And so this is like a refresher, right? This is like a refresh at this point. So on a position time graph, what does slope represent? And slope represents velocity, right? Velocity is slope on a position time graph. And feel free to pause the video if you are copying this down because I will move on. So pause now, right? So let's say, but now we know slope means velocity now, right? We know that slope means velocity, but well, what's the difference between a positive slope and a negative slope? Right, so which section shows you a positive slope, essentially being a positive number, positive slope? And what does that mean? Well, in between 0 and 2 seconds gives you a positive slope. So this is a positive slope here. So 0 to 2 seconds. And what does that mean? Well, if we know slope means velocity, well, then a positive slope will just mean a positive velocity. And so you're traveling in the positive direction. You're traveling in the positive direction, right? You're traveling in the positive direction here. So traveling in positive direction. And well, on the other hand, which shows you a negative slope? Well, this from 4 to 8 shows you a negative slope. And what does that mean, right? So from 4 to 8 seconds. And then, well, that means negative velocity, which means that your object is traveling back in the negative direction. So now your object, which makes sense, right? Because we start at 8 here, we end at 0, and we're essentially traveling back in the opposite direction. So we're traveling in the negative direction here. And so that's what that means, right? So we're traveling in the negative direction if we have a negative velocity. Let's move on. Feel free to pause. So for the most part, we've been dealing with straight lines, right? So constant slopes. But now I want to introduce to you a different line, right? So you guys have been used to this blue line, right? This blue line right here. But now, well, let's say the line is curving. So let's say on a position time graph, the line is now curving. And so what does that mean? Right? What does that mean essentially? Well, let's try to figure out what the slopes are first, right? And I'll help you better understand what the two differences here are. So the slope of A again is delta y over delta x. So it's delta y, delta x. So your y goes up 2, x goes 1, 2 meters per second, right? Because it's velocity, we know slope is velocity. B, same thing, 4, 2. So 4, 2, 2 meters per second. C, same thing, 6 over 3, 2 meters per second. 8 over 4, 2 meters per second. And so we can say here that, well, if it's a straight line, clearly you see that it's traveling at a constant velocity. We know that slope means velocity. Well, the straight line right here means constant velocity, the straight slope. Well, on the other hand, what does a curved slope tell you, right? So let's take a look at it here. So this is 1, right? So E is, your change in Y is 1. Well, that doesn't really look like a 1. 1 over 2, which is 1/2, so that's 0.5 meters per second. F, your change in Y is 2, your change in X is 3, right? So that's 3, so that's 0.67. For G, it's 4. For X, it's 4. So that's 1 meters per second. For H, it's 8. For X, it's 5. And so that's 1.6 meters per second. And so what's happening to your velocity now if your slope is curving on a position time graph? It's a changing slope, which means that, well, I should have written changing. So it's a changing velocity. Right, it's a changing velocity here now. And so clearly, well, on a position time graph only, I have to stress this is a position time graph only. Well, the difference here between a straight slope and a curved slope is that, well, one tells you that it's traveling at a constant velocity, right? So this line right here tells you at a constant velocity. And the other line tells you that you're traveling, your velocity is changing, right? This is a changing velocity. And what does that mean, guys? What does that mean? Well, if you have a changing velocity, you must have acceleration. You are accelerating. You are accelerating. Right? And so the notes are here. Take some time to copy it down, right? If you have your notes, feel free to copy it down. Pause it at this point in time because I am going to move on. And I'm just going to repeat this verbatim. So a constant slope represents constant velocity, right? So a constant slope, So right here, so constant slope, constant velocity, constant slope, constant velocity. And a changing slope represents change in velocity. So a changing slope, changing velocity. So this means you have acceleration. So you have an acceleration. You are accelerating. You have A. You are accelerating. Your velocity is changing. All right. So let's take a look at this graph. Now I want you guys to tell me again, we're going to draw this again, what does a graph look like if you're at rest? Well, if you're at rest and you're at a position of 5 meters, let's say you're a position of 5 meters and you're at rest, well, you just stay there. Right? You're not moving, so next second you're still at a position of 5 meters, you're still at a position of 5 meters. Right? So, for example, you're still going to be here. This is 0 meters. So you're not moving from a position of 5 meters, and so it's going to look like a straight line. a straight horizontal line. A horizontal line. I have to clarify that. A straight horizontal line. Alright, and so that's what at rest on a position time graph looks like. Let's apply that. So, and now we're going to decipher, we're going to figure out what these graphs mean, what these four graphs mean. And the easiest way, and this is something you should copy it down in your notes, the easiest way to decipher these curved position time graphs is, well, we have to figure out, do they start at rest or do they come to rest? And if they are starting at rest, which means their initial velocity is 0, then and the slope curves, well, then you're speeding up, right? Your velocity is changing. If they are coming to rest, well, that means they are slowing down. Right? So feel free to pause and copy down the notes, and let's do some practice. Right? It's better to do some practice here to figure out what I mean. So we want to label each graph as either starting from rest or coming to rest. So let's take a look at the first graph. And again, we're looking for a horizontal line, right? Because that's what it means to be at rest on a position time graph. You're looking for a horizontal line. Well, if you take a look at this graph, you can see that this graph right here makes this line curves and then slowly comes into a horizontal line. And that means it's coming to rest here. It's coming to rest. And if it's coming to rest, where if you're coming to rest, your final velocity is 0, well, it means you're slowing down. Well, then this means you are slowing down. So make sure to write this on your notes. Let's take a look at the second graph. Well, are we starting from rest or are we coming to rest? And take this time to maybe answer this yourself. Well, if we're here, it looks like, well, we're starting from rest, right? You kind of see this horizontal line here. And that means we are starting from rest. And that means we are speeding. We're speeding up. Let's take a look at the bottom graph here. So this graph right here is saying that, well, if you look at it, you're kind of coming to rest. Right? You see this horizontal line here at the end. So that means you're coming to rest. And if you're coming to rest, you are indeed slowing down. Right? You're stopping. Let's do the final one. Well, it kind of looks here that you're kind of starting from rest, right? You see this horizontal line here. So you're starting from rest. And that means you are speeding up. All right. If you haven't finished copying this now, feel free to pause the video before I move on. We'll move on right now. Please pause. So, take a look. So which graph shows you an object traveling in the positive direction, speeding up? Well, you know it's traveling in the positive direction, right? So how do you tell if objects go in the positive direction or not? Well, again, this is 0, right? This is 0. And if you go in the positive direction, that means you're going away from 0. You're going towards the positive direction. We know a positive is above 0. So which graphs show you something traveling in the positive direction? Well, let's label this. So graphs A and D do show that you are traveling in the positive direction. So that's how you can tell, right? Because it's going away, going upwards, up from 0 in the positive direction. And so, well, which ones shows you speeding up, right? Although A and D show you traveling in the positive direction, only one of them show you speeding up. And the one that shows you speeding up is actually graph D. Because in graph D, you see that the object is kind of starting from rest. Right? So it's speeding up because you can tell because it's starting from rest. And the line curves. Right? The line curves. Now let's do the next question. Well, which object is traveling in the positive direction and slowing down? Well, we already know, right, the definition of, we already know why. That's why. But which one shows you slowing down? Now this one, right, this one shows you slowing down because it's kind of coming to rest, right? So you're coming to rest here. That's how we can tell. So coming to rest. It's curving. The line is curving. Now, I want you guys to figure out, well, which graph shows me objects that are traveling in the negative direction? Well, if you're traveling in the negative direction, that must mean you are going towards the negative directions, right? So you're going towards 0, right? So we can tell because you're going towards 0. And the same thing right here, right? And, well, which, let's do 3, right? So which one shows you speeding up? Which one of those shows you speeding up? Well, B is going to show you speeding up because you are starting from rest. You see that horizontal line there. You're starting from rest. Starting from rest. And which graph shows you slowing down? Well, graph C shows you slowing down, so that because you see it's coming to rest. Coming to rest. So it's this one's C, this one's B, this one's A, and this one's D. Right? Alright. Good. Feel free to pause if you still need to copy this down. And so that's how we kind of interpret position time graphs, right? We interpret curving position time graphs like that. Now let's move on to interpreting slope on a velocity time graph. So again, what does the slope on a velocity time graph represent? We did this last lesson. Slope on a VT graph represents acceleration. Right, so that's what you learn, right? Slope on a VT graph represents acceleration. That's what we learned. And so 3B says, which sections of time show you a positive slope? What does that mean? Right, so we see positive slope. Again, these are positive slopes, right? They're going upward. You have an upward slope. So the times you see a positive slope are being in between 0 to 3 seconds and 10 to 11 seconds. And what does that mean, right? If we know that slope on a VT graph means acceleration, then a positive slope on a velocity time graph means a positive acceleration. Now the other question says, well, which parts of this graph show you a negative slope, which means a downward slope, right? So it's from sections, or from times 3 to 7. From 3 to 7 seconds. That's a negative slope. And what does a negative slope mean? Well, a negative slope means negative acceleration. All right. Negative acceleration. Okay, that's what that means. So based on lesson 2.1 was a rule for signs on both velocity and acceleration for speeding up and slowing down. Well, in lesson 2.1, you should have learned that our rule is that, well, there are signs of both velocity and acceleration for speeding up are the same signs, right? We must have these same signs if we're speeding up for both velocity and acceleration. It can either be positive v or positive a, or negative v, negative a. And for slowing down, well, we must have opposite signs for slowing down. So it must either be positive v or negative a and negative a, or negative v and positive a. And so that's for our signs for slowing down. Now this is really important because now we're going to decipher velocity time graphs. And this next question here, which sections show you speeding up and which sections show you slowing down? So let's take a look at it. So from 0 to 3 seconds, what velocity do you have? You have a positive velocity because you have a positive slope, right? Not only that, furthermore, the numbers are positive. They're above 0. What about your acceleration? Well, we have a positive acceleration here because it's a positive slope. And also, the velocity is not positive because it's a positive slope. The velocity is positive because of numbers. I'm sorry. That was a mistake. Your acceleration is positive because you have a positive slope. Your velocity is positive because of these numbers over here. It's above 0. I apologize. So if we were to do it again, let's do it again. You have a positive velocity because of these positive numbers over here. And you have a positive acceleration because your slope here is positive. That's why. So from let's do 3 to 5. From 3 to 5 seconds, is your velocity positive or negative? Well, your velocity is positive because, again, these numbers here are positive. But because you have a downward slope, you have a negative acceleration. So here you're speeding up, which makes sense because the y-axis says you're going from 0 to 20. But here, on this section, you're actually slowing down and that also makes sense because you're going from 20 to 0, so you are slowing down here. From 5 to 7 seconds, is your velocity positive or negative? Well, from 5 to 7 seconds, our velocity is negative because we do see the y-axis over here, right? It's negative. What about our acceleration? Well, acceleration here is also negative because we have a downward slope here. And so what this section says, it's speeding up, right? They have these same signs. Furthermore, you're going from 0 to negative 20. You are speeding up in the opposite direction. Now from 10 to 11, we have a negative velocity, right? Our numbers are still negative. And our acceleration here is positive. We have an upward slope, and because they're opposite signs, we are slowing down, which makes sense because we start at negative 20 and we end at 0. So which sections show you speeding up? 0 to 3, 10 to 11. I'm sorry, 0 to 3, 5 to 7. And 3 to 5, slowing down, 10 to 11. All right, feel free to pause if you're taking down notes. So let's do some practice questions now. So which paragraphs represent the same motion? Well, this is one of your homework. Well, it's not really a homework question, but let's figure it out. So let's take a look at these graphs. Let's take a look at these graphs. Now, and the easiest way to kind of go through these problems is, well, we first should take a look at what our VT graph is saying. We're always going to take a look at what our VT graph is saying because that's the easier one to kind of tell what's going on. And then from that point on, we have to figure out, well, does it match our PT graph? So let's take a look at our VT graph. Let's take a look at our VT graph. Let's take a look at what this is saying. All right, let's take a look at what this is saying. Well, it looks like our velocity is, well, we're definitely increasing, right? So this is a positive number, so it's going upward. So our velocity is increasing. So our velocity is changing. And if we have a changing velocity, well, what do we have? We have an acceleration. So we are accelerating here, right? We are accelerating. And we know that if we are accelerating, let's go back to here. If we have a changing velocity, right? Let's read this. If we have a changing velocity on a position time graph, our line must curve, right? And that's this red line here. That's what we learned in 1B. And so we're talking about two different graphs here. If on a VT graph you realize that your velocity is changing, well, then that must mean that your PT graphs must curve, right? If you have a changing velocity. So clearly, automatically, B, C, and D are incorrect. Your line in the PT graph must curve, and because you don't see any line here, it's automatically wrong. And so you're left with A, and A is your only choice left. Well, let's kind of figure out why A is correct. This is showing you, right? This is your velocity is staying the same. So we can say that this is a constant velocity. And a constant velocity, well, our PT graph cannot curve. It's just going to look like this slope here. And that's the accurate thing here, right? So if we have a constant velocity, our PT graph will not curve. And that's really it, right? That's really it. Feel free to pause if you're copying this down. So for B, which graph represents the motion of an object traveling at a positive velocity and a negative acceleration? So when you read this problem, you should really just kind of focus on two things, right? The object is moving with a positive velocity and a negative acceleration. And once you see the word acceleration, you should realize that, well, a PT graph will curve. PT graph will curve. Which means that you can basically cross out two of these choices. And you're left with B and D. Well, next part is you have to realize that, well, this is a positive V and this is a negative acceleration. And if you have opposite signs, you are slowing down. And which does B or D look like an object is slowing down? Again, if we're slowing down, we're coming to rest, which means we should have a straight horizontal line when we're coming to rest. So which graph shows you slowing down? Well, graph B does. Right? You see a straight line over here, which means it's at rest. So you're slowing down. So the only choice here is B. All right, take a picture before, or copy down the notes before I move on. Feel free to pause the video. And so now we're at our final practice question. Which pairs of graphs represent the same motion of an object? Well, let's just take a look at these graphs. Let's start with D. D is saying that your velocity is positive. You have a positive constant velocity, right? Your velocity is not changing. Let's say this is like 5 or something, and so your velocity is not changing, constant positive velocity. And well, if you have a constant velocity, your PT graph cannot curve. Your PT graph will not curve if you have a constant velocity. So that's wrong. Let's look at this. This is a negative, say negative because it's below 0, right? It's negative constant velocity, right? Your velocity is not changing. That means you're traveling in the negative direction. That means you travel in the negative direction. But what is your position time graph saying? Your position time graph saying is that you're traveling in the positive direction. So that's what your position time graph is saying, traveling in positive direction. So these two graphs don't match. This VT graph right here says you're traveling in the negative direction. This PT graph says you're traveling in the positive direction. So that's automatically wrong. So let's look at C. So C is saying that your velocity is changing, right? So you have a changing velocity, which means you are accelerating, right? So you are accelerating here. And if you are changing velocity and you're accelerating, well, your PT graph must curve. And well, does it curve here? Nope, it's wrong. And so you're left with A. It makes sense, right? So this is a changing velocity. And so, well, your graph must curve. Must curve. All right, and so that's the end of the practice question. This was a long one, and I mean, this could take 2 periods in class, so it is a long video.